All right, hello everyone. Since I am not able to be with you today, I've just got 8 or so problems that I want to walk you through to remind you of some of the things that we talked about before going on fall break. Okay, so the first one on this worksheet that you're going to be working on today is number 2, asking two things. The first thing is asking to find the derivative, and the second thing is to find the derivative at some c, and number 2, c is -1. Okay, so I want to start by reminding you that this is actually just a power rule problem if you rewrite the function. So 1 over x can be rewritten as x to the -1. -3 over x squared is the same as -3x to the -2nd. Plus 4 over x to the third is the same as x to the -3rd. So now we can take this derivative. Okay, if you remember, the rule of taking this power derivatives is to multiply. So we're going to take -1 times 1, which is -1, and then we're going to subtract 1. -1 minus 1 is going to become x to the -2nd. Then we're going to do it to the next piece. -2 times -3 is +6. We subtract 1, x to the -2nd becomes x to the -3rd. -3 times 4 is -12. If we subtract 1, we get -4. And this is one answer that's acceptable. Another thing you might also see, which I like a little bit better, but it really doesn't matter, you may go ahead and take these negative exponents and rewrite them back as fractions. So you may also see -1 over x to the 2nd plus 6 over x to the 3rd minus 12 over x to the 4th, and that also works. Okay, second part of this question asks us to then take our derivative and plug in -1. So we end up with -1 over -1 squared plus 6 over -1 to the 3rd minus 12 over -1 to the 4th. And -1 over -1 squared is just -1 minus 6 minus 12. So the second part of this would be -19. As the first few you have are going to be very similar to this, okay? Practicing that power rule and getting some repetition. Okay, next one I want us to look at is number 10. Okay, number 10 also reminds you that this is a power rule, so find the derivative. Make sure that when you write it, you label it the derivative. And I wanted to talk about this one because a lot of us are going to look at this and see a fraction and think that we may possibly have to use the quotient rule, which was the last thing that we talked about before going to fall break. So I want to remind you that this 1/3 can be factored out and written out in front. So we have 4x to the 2nd, right, minus 5x plus 6 times 1/3. And I do that because when we write derivatives or take derivatives, anytime we're multiplying by a constant, we can leave that constant out in front and just take the derivative of everything else. So we're going to do this like the last one. We're going to multiply. 2 times 4 becomes 8. X to the 2nd minus 1 just becomes x. Okay, there's like an imaginary 1 here, so we multiply. We get -5. X 1 minus 1 goes to 0, and that goes away. And the derivative of a constant, 6, is just 0. And so we are now done with that one. Okay, finding the derivative. Again, it's important to make sure that you use proper notation and label that this is the derivative on that whole set of questions. Okay, 14 also asks us to find the derivative. But I want to remind you, again, that when you look at this, at first glance, you may think, okay, well, we're dividing two things, and we're going to have to use the quotient rule. And you can use the quotient rule. However, it's going to be a lot longer than it has to be. So I want to remind you that you could, when you see just dividing by a single piece, mentally think about this as divided by x squared divided by x squared divided by x squared divided by x squared, all individually. So you can rewrite y as x minus 3 plus 10 times x to the negative 1 minus 5 times x to the negative 2. And then you can take the derivative, again, just using the power rule. So the derivative of x is just 1. The derivative of this constant is 0. Okay, if we multiply, this becomes negative 10x to the negative second. And then the last piece here becomes positive 10x to the negative third. Okay, so the derivative is going to be 1 minus 10 over x to the second plus 10 over x to the third. Okay, so sometimes you can use algebraic manipulation to make the problem a little bit easier than it has to be, or than it could be, I guess. Okay, now here's a case. If we try to divide, right, we don't just have a single x, we can't just split it up. So this is a good reminder of that quotient. Okay. Okay, so there's a formula you have in your notes where we can call this upper function f of x and the lower function g of x, and you can look at the formula. We said the other way, the shorthand, is to call this upper function the high function and the bottom function the low function. And the phrase to help us remember was low d high minus high d low over low low, which represents low to the second power. Okay, so here's what that looks like. We're going to take the low function, so y prime is equal to the bottom function, which is 2x plus 3, times the derivative of the upper function, or the high function. The derivative of 3x minus 2 is just 3. A minus. Now we're going to take the high function, 3x minus 2, times the derivative of the bottom function, or the low function. The derivative of 2x plus 3 is just 2. We're going to take all of that divided by low squared, which is the bottom function squared. So 2x plus 3 squared. Now eventually we may get to where we have to simplify this, but for now I'm going to let you stop there. Okay, once you get the setup, and eventually we'll talk about the algebra. If you wanted to, you can multiply by 3, right? Combine your like terms. It will probably clean it pretty nicely, but this is for now what I want to see, that you can get the setup and get the quotient rule properly. Okay, 28 asks us to find the equation of the tangent line to the graph at the indicated point. And then you can use your calculator to confirm the results. So the good news is I'm giving you a full point here. I'm giving you an x1 and a y1. Okay, when we write the equation of a tangent line, we have half of what we need, right? We have y minus y1 equals, we have some m times x minus x1, which is 2. So here's what my answer is going to look like. Okay, what we need to find here is the slope of this tangent line. And we know the slope of the tangent line is the same as the derivative. Okay, so I'm going to take my function and I'm going to find its derivative. Again, we have a fraction, right? And it can't just be simplified by dividing, so I'm going to use the quotient rule. So I have a high part of the function and a low. Okay, so to find this derivative, we have low x minus 1, d high, the derivative of x to the second is 2x minus high x squared, the derivative of x minus 1 is just 1. All divided by x minus 1 squared. Okay, so I found my derivative. We need to use that to find the slope of the derivative where at x equal to 2. Right, all of the derivative is in terms of x, so we're now going to take the derivative and we're going to plug in 2. So we're going to find the derivative at 2. So we get 2 minus 1, which is just 1, 2 times 2, which is 4, minus 2 squared, which is 4 times 1, all over 2 minus 1, which is 1 squared over 1. Okay, so we get 4 minus 4 over 1, which is just 0 over 1, which is just 0. So once we get the slope of the tangent line, we can come plug it in. Now this is kind of a weird one, right? Because when the slope of the tangent line is 0, that's just going to leave us with y minus 4 is equal to 0, which gives us the line y equals 4. Okay, so let's just talk about that. I haven't graphed it, but if I were going to put this in the graphing calculator, okay, and I don't know what the function looks like, but say we have some function. If the slope of the tangent line is 0, okay, so here's the point we're going to say 2, 4. If the slope of the tangent line is 0, what we expect to happen is the tangent line of the function, we have a 0 slope, which means it's going to be a horizontal line. Okay, again, the function is not a horizontal line, but the slope of the tangent line, it should be a horizontal line, which means the graph is going to have some sort of turn or, something that's going to make that happen. All right, 32 and 33 tell you to find a normal line, which you can skip. If you want the practice, just a side note, normal line is just perpendicular slope. So if you find the slope of the tangent line, right, by using the derivative, to find the normal slope, you're going to use opposite reciprocal. So if you had 3, it would become negative 1/3. Okay, but if you want to skip it, that's okay. If you need the practice, I would advise you to go look at the posts too, and then we can give you the answers when we get back. All right, so I think 36, maybe one more. After 36, I think I'll do 36 and one more, and let y'all do the rest. 36 says determine the points at which the graph of the function have a horizontal tangent. Okay, so let's decode a little bit. We know that tangent is the same as the derivative. Okay, horizontal lines have a slope of 0. So we want to find horizontal tangents, which is just places where the derivative is equal to 0. So in order to do this, we're going to start by taking the derivative. Okay, using the power rule. So we have 3x to the second minus 9. We're then going to take the derivative and we're going to set it equal to 0. Okay, so I'm going to take 3x squared and add 9 to both sides. And divide by 3, so x squared is equal to 3. When I take the square root, I get x is equal to plus or minus the square root of 3. Okay, so I found where. If you look at the directions carefully, the directions say to find the points. So my answer is going to be square root of 3 something, negative square root of 3 something. Okay, to finish this problem, we're going to take our x values and we're going to plug it back into the function. Okay, so I'm going to start by taking f of the square root of 3, and that's square root of 3 to the third minus 9 times the square root of 3. The square root of 3 to the third, if you don't follow this, is root 3 times root 3 times root 3. Okay, root 3 times root 3 is 3. So root 3 to the third is just going to be 3 root 3. Minus 9 root 3, which is negative 6 square root of 3. I'm going to do the same thing, but this time I'm going to plug in negative root 3. So I have negative root 3 to the third minus, no, sorry, this time it will be plus, right, double negative. So I get negative 3 root 3, because this time it would be negative, negative, negative. So negative plus 9 root 3, which gives us positive 6 root 3. So negative root 3, 6 root 3 would be my second point. Okay, so this right here would be my final answer because it asks for the points. All right, so here's the last one we're going to look at. We haven't done a lot of these just yet in class, but we're about to get to them. Okay, we're asked to find h prime, or the derivative, at 4. Okay, we're given a function and we're given a little chart. So let's first talk about how we would find the derivative of h. And I like this one because this time two things are being multiplied. And since two things are being multiplied, we're going to have to use the product rule. Okay, product rule said we're going to take the derivative of the first piece. The derivative of x squared is 2x times the second piece. Product rule has an addition. So then we're going to leave the first piece the same and take the derivative of the second piece. Okay, so I'm now going to take that and I'm going to plug in 4. So we have 2 times 4, f of 4, plus 4 to the second times f prime of 4. Our 2 times 4 we know is 8, and 4 squared is 16. So let's talk about how we finish this problem. And I don't have it up on the screen, so you might have to look at your paper, but there's a chart. And if you look at the chart, they give you that f of 4 is equivalent, right, to negative 8. And they also give you f prime of 4, and f prime of 4 is equal to 3. Okay, so once you get those values and you substitute, then the rest of it is just a matter of simplifying. So 8 times negative 8 is negative 64. 16 times 3 is going to be 48. And 48 minus 64 gives me a final answer of negative 16. Okay, so I think that that's enough for y'all to go ahead and get started. Okay, good luck, and I will see you on Thursday.